All right, so with that said, all the design load, and especially sulfate dead load and superimposed dead load and live load. So let's learn basic of ETABS. So what you see, I already create and simple one bay, the steel framing using column and beam and slab, right? For the 30 by 40 bay. So I uploaded this to ETABS example file, but you can start to open it and run that the model, and you can check the design of the member forces. Because it is the beginning and the first class of the ETABS, I will give you the brief introduction of how to get started. But before I record it, I will kind of show you some the example. So let me just uncheck it. All right, so this model has a slab. I assigned some deck 1 properties. I will show you later, but I'd like to check any loading. Oh, I don't have a loading yet. All right, so let's get started. So this is I draw that all line and column and metal deck and section property. You see that deck 1. So I think you're using defaults. So I want to make sure, and then adjust the section property. Go to define and deck section. All right, default deck 1. I'm okay. I have a 3-inch metal deck plus 3.5 inch concrete topping. You see this, the field deck has a profile metal deck with filled with the concrete, right? T sub C is concrete topping above the metal deck, so I want you to recognize this is tied with our previous metal deck self-weight calculation. But for now, for consistency, I'll change it. The deck 1, maybe I'll name it 3-inch metal deck plus maybe 3.25 lightweight slab, right? So, or just choose a normal weight, because I don't later on normal weight metal deck slab. So this 4,000 psi is normal weight concrete, and what I'm gonna do is I'm gonna change the concrete topping here, T sub C, right? You see the T sub C is above the metal deck. So total slab, the metal deck slab is 3 plus 4.5, so 7.5 inch thick slab. So other stuff, I will just keep it as a default. So I have only one section properties. So since I updated, you'll see automatically change section properties. 3-inch metal deck plus 4.5 inch normal weight concrete. All right, so column is there, girder is there, right? And this, okay. And I'm gonna just set it up the loads pattern and with the load cases. So I open it, default, always showing dead load, dead load type 1 self weight multiplier. This means ETABS will calculate automatically their structural elements, their self weight. All right, for our superimposed dead load, I'm gonna create another load cases type with the type superimposed dead load. Make sure you don't, this one should be 0, otherwise you double count the self weight, right? So dead load including self weight of structural element. Superimposed dead load, we're gonna assign the uniform area load. Live load also we're gonna assign as uniform live load. So I set it up this load pattern, and I'm gonna select this. Now make sure your unit is always somehow switched here. You could change the unit, consistent unit. Okay, the default is I use a pound per foot, but for the uniform loading purpose, assigning purpose, I using pound per foot. So I select the beam slab, go to assign. Here's the shell element, shell loading, and uniform load. So dead load, I'm gonna keep it as a blank because ETABS will automatically calculate their self-weight. But superimposed dead load, I'm gonna assign some sort of 20 psf pound per square foot as my flow finish or mechanical, electrical, plumbing load. Typically 20 psf is kind of minimum we use, but load direction is default is gravity, so this is a gravity load. So 20 psf will be pointing down. So if I apply it, right, and right click, you see the 25 pound per square foot is assigned, right? You have to deselect and change to live load. For the live load, I assigned 100 psf. All right, so I assigned the load. This model is geometrically done. So this case, one thing that I need to make sure, because this is 3D analysis, I have all the column and pin here, so building might be not stable, but also I'm gonna make sure all the boundary condition is pins or fixed. So here I want to make sure that each beam to column or beam to girder and girder to column connection is what? Okay, here. Okay, got it. So this example, what I did before, this column has a pin base, but they are moment connected, right? So girder to column is a moment frame, so it can develop lateral bending stiffness. But the beam to girder, right, has a pin connection. You see the dot. Let me change the graphic preference. Okay, see the dot? That means moment release. So if you right click, you see the end release as a torsional moment and shear. All moment 2 and moment 3 is all releases both end here. Moment 2 and 3 at each end, I and J are released. So this means it's simply supported. So you been studied that the beam with the pin and roller is really reflected like this in the 3D building. So let me just run the model and we'll check the shear force diagram and bending moment diagram. Alright, the first thing is the deflection. You don't have to worry about this. I think this is a graphical, but first of all, we're gonna check our moment diagram. So here we have 3 load cases: dead load, SDL, and live load. If you are interested, let's turn on the bending moment diagram, right? Okay, so there is some moment rigidity. Okay, all right, so let's see. So okay, based upon self-weight moment diagram, let's focus on this 2 beam in the middle, because a single curvature, the bending moment diagram representing the beam has a moment released. It's both ends, right? Shear force diagram under the uniform load is this kind of slope, right? Constantly slope. This is something we're gonna everybody understand, the moment diagram and shear force diagram based upon your beam the study. Those are all can be reflected on this 3D ETABS analysis, right? Obviously, SDL loading, because their magnitude is slightly different, so that under different load cases, you're gonna have a different number, right? But the overall shape should be similar. So you can turn on and off that value. But diagram, moment shear force diagram, bending moment diagram, you need to check it whether this will make sense or not. And for design purpose, yeah, we need to set it up load combination. We are following our Eplin method. So if you set up the loads pattern and cases, you can use the default design load combination setting. So these cases, I'll just for now stay with the steel framing design, so that I'm gonna bring this load combination. Typically S1 is 1.4 dead load, right? S2 is 1.2 dead, 1.6 live load combination. I'm sure everybody understand. D1, D2 is maybe for deflection check, right? Dead load SDL is just pure service dead load. D2 is service dead plus live load all together, right? So this is load combination, typically use it. But for our composite floor framing design, we're gonna use composite floor framing. So I'm gonna record it separately. But this is just for ETABS 101 session that you can download that model and run and check the forces. So I want you to get on board and just practice SAB and ETABS all together. So I'm gonna just pause here. All right, so briefly then, how to get started this ETABS. All right, so now I'm gonna give you just briefly how I can just start setting up the ETABS model and draw all the column and beam and slab. So I'm gonna just go to open new model. So when you open, let's see, maybe I can start from 0. So let's say if you open the ETABS, you'll see this, and you can just click the file and open new model. The model initialization, typically Imperial, right? US Imperial is default, so you just click and open it. Now there is some template. You can set it up, the X, Y, and the grid. Also, once you fill in number of grid and number of spacing dimension, right? You can, the ETABS will set it up in the grid system based upon your input. So let's say if I type 4 grid, one in spacing 30 feet, Y direction spacing 40, the floor to floor height is 15, and number of floor 10. If I click that, you'll see the grid like this, right? X direction is 30 feet and Y direction 40 feet, right? So it showed 10, but it doesn't matter, but I will just choose the story 1 here, story 1, right? So I'm gonna just draw the column. So now there are many different ways you can start it, but let's start with the column. So I click the column, quick column, the button. You see the properties, lateral column and continuous. I'll just keep it for now. I click it, I move this cursor at the intersection point. I click and draw the column and drop the column. So you see that all the column is already shown here. Second one is I'm gonna draw the beam. Since I have a grid, maybe either I can click this, right, beam, but this one has a section property a lateral beam. Also moment release is continuous, so no moment release. So I can draw, click, right click, but you could stop this, or I think we can use this quick draw. Since we have a, let me see, does this one work? Okay, since we have a nice grid in Cartesian coordinate system, you can use this quick draw by clicking the grid as well, right? So mostly you using this two draw beam feature. Now third one is let's add another filler beams, because this is 30 feet and 40 feet, which we choose one direction or typically the longitudinal long direction for the filler beam. And I mentioned about that spacing. Typically we using 10 feet is a good starting point. Over 30 feet column spacing. So I'm going to click this quick draw secondary beam. You'll see that there's a composite beam, but this typical composite beam has a moment release, but default is number of beam is 3. If you hover the cursor, you see that dash line, right? Red color. But I need a 2 beam only. This default is Y direction. Now you see that two beams, right? If you click it, it's automatically added. So now click this, so you see that all beam and is all drawn. Now it's time to add a slab, right? So same thing, similar way, either you could click this draw floor button, but you need to change the section property either using this polygon draw the floor, or if this is rectangular, you can use this 2-point method, right? So since we have a default slab 1, let's keep it. Either you can click and you can click, or if you can, since this is rectangular, I can click here. Oh, I can click and drag it and drop here, right? So I think you can just practice a few times, you know it. This is kind of no-brainer. Something is pretty much similar to any software. So now, because I keep the section property default, it should have a slab 1, but we need a metal deck slab. Slab 1, let's check our section properties here. Define, right? Go to section property here. There is a slab section, deck section, right? I think default slab section 1 is typically concrete slab. Default is 8-inch slab and normal weight concrete, 4,000 psi concrete, but we're not going to use it. We're going to use metal deck slab. So metal deck slab, there is a default deck 1, similar to what we did previously. I'm going to use a 3-inch metal deck, 4.5 normal weight concrete, right? Maybe slab. So here 3-inch metal deck and 4.5. I'll keep the concrete strength 4,000, which is normal weight concrete. I keep it, right? I create the section property for the deck, and now I'm gonna select, click this, assign shell, and assign the section property with deck. So deck is 3-inch metal deck, right? So I assign and see. All right. So because metal deck is collocated, there should be spanning perpendicular to the beams so that they can sit on series of beams, right? If you happen to kind of draw it, but if you end up somehow deck oriented 90-degree rotated, let's say, I'll show you shell. Where is the orientation? Local axis. Yeah. So let's say somehow you draw and assign the deck, but if you end up with this, obviously this metal deck is spanning all the way 40 feet span here to here, which is not possible, right? This metal deck is collocated, it's not very steep, cannot span 40 feet. We keep telling that the metal deck is a 3-inch metal deck. It only can span 10 feet plus minus, right? So this is orientation is very important. So if you somehow if you see this, you need to select and go to assign, go to shell, the local axis here, and orient it either 0 or 90. So I put this 0 and it's rotated 90 degrees. So metal deck is spanning along perpendicular to the beams. Right? All right. Now, so we are getting close. So now we're gonna assign the load. Same way. Go to load pattern. Okay, default has a dead load and live load, but I'm gonna add superimposed dead load. So dead load one with the self-weight 1, live load and STL. I set it up and ready to assign the load. So that I click the metal deck slab, go to assign, go to shell load, uniform. That load is self-weight. I don't want to assign any other additional loading. But STL, I'm going to assign 20 PSF. Just check the unit always, but direction is in the into the gravity direction. So you see that when you click it, it shows it in the beginning. And second, select again, go to live load, change to 100, and assign it. So, right? Once you see it, it's turned up when you refresh it. This guy. right? This button still doesn't work while recording it. Okay, click this. Why this button doesn't? Okay, see, so after when you refresh it, this force loading is turned off because only it show when you assign it. In order to check or display, go to display, loads, then shell. You can click SDL. You can turn on. You can change to live load. You can apply. So you can visually you can turn on and check it. Also, meanwhile, other way you can select and right click. There is a tab on loads, so you can check the load, right? So this is all set. So I think this, I'm looking here, we have a boundary condition at the bottom of column. I think we're ready to run it. So I'm hit the button. So this is a bay. Okay, so analysis is done. So let's click that forces, dead load moment. See that moment diagram? It's a single curvature. Since we don't have a moment release, this one is double curvature, right? Negative moment and positive moment and negative moment. So the only pillar beam has a 2 moment release at each end, so it's bent like a simply supported beam. So here has a single curvature moment diagram, right? If you want to turn on the value, you could turn on the value and see the number, right? And I turn off. So I want you to just kind of practice this live load, so that this moment diagram and the moment shear force diagram you should be able to calculate by hand. Basically, you know, the uniform load times tributary width of the beam is typically 10 feet. So if we have a live load 100 psi times tributary width 10 is 1000, right? If we can choose 1000 pound per foot, 1 kip per foot, times the length W, L is 40, so WL squared divided by 8 is the moment, maximum moment for the uniform load, so that you should be able to calculate the moment, and shear as well. All right, so I want you to practice up to this. So next week, I want everybody just kind of be familiar with, and you can play around this a few times. And then for the next couple of weeks, we need to just speed up and try to study entire typical floor framing beam for the beam building in the building system. Okay, so I'm gonna stop here, and if you have any question, email me. Okay.